Hello, fellow DRE analysts. Sean here with a demo of the automated DRE version 1.11 release. We've moved the fab identifier to the home page, and we've created this option here to be able to add a new fab. And we've also added this option slider to the home page where we can distinguish between the different types of network access or storage access and sampling types. So for storage, we can either push it to the cloud like we have been doing, or we can only write it locally. If you have it in cloud storage mode, it'll also write a local file in addition to sending the payload. For sampling types, we have simultaneous, which is what we currently have been running. And I've added this sequential option, sequential meaning sequential in time. So for example, you would measure the inlet, and then at a later time, you'd measure the outlet. This might be ideal for like an in situ plasma. I want to, before I go on any further, I want to draw your attention to this view menu bar at the top, system status. Here we have a dialog that pops up where we have the mass flow controller set points and readings, and we have the relay states of the solenoid valves on the inside of the cabinet. So as you're running, you will moving through the pages, you will see these numbers automatically change depending upon the situation, the set point, and you can refer to this to view your actual flow rate and validate that you're getting the proper flow. This kind of circumvents the need for having to go around to the back of the cabinet and manually look at the rotometers. These light indicators will turn green if the values are very close, and then have a yellow if they're kind of close, and then obviously red right now. You can adjust these at any point in time. So I could adjust it now and set it to some value, and the MFC it'll send it to the MFC, and the MFC will set to that point. So you can use this to kind of gain full control over your cabinet outside of what's automatically done through the pages. Same thing with the relays. We can toggle these states to turn on and off certain features or certain solenoids that cause certain events in the cabinet. So we can kind of do whatever we want here. And this screen you can keep open or open at any time just to monitor or to change any of the set points or the relay states. Okay, moving on. We've got some the same pages here and here. One thing that we've done is that we've stored a lot more of the flow information than had previously been done. And if you want to view that information now, you can click this measure button and click next. And you'll see that the fields down here get populated with the previous information. This differs from the previous versions where this information was not retained. Instead, just the aggregate total was retained. But now we're storing all of this information for future use. And this is how you can view it. We'll step through again, step through again. Now we arrive at the big screen here. This should recognize these absorbance spectra. But we have these tabs now on the side, and you'll see that we have maybe a few new buttons down below. I'll come back to the buttons in a minute. But because we're familiar with this page of the absorbance spectra, let's go ahead and step on to the time series plots. Now this is a completely new feature. So we have our compound list here, and note that the compounds that are decided to enter this list are determined automatically by the intersection of the names in the inlet and the outlet new wave instances. So if you wanted to add, say, a new compound to your analysis, just add it to the new wave inlet method and the new wave outlet method with the same name. And when you come to this page, it'll automatically populate in this list. So here we have our inlet time series plots and our outlet time series plots time. And notice the units here we're actually recording them in flow rate. This way the two plots can kind of be compared more easily with the eye. And we can click on any of these compounds to view our time series plots. And you're welcome to click on as many as you would like and view them all at the same time. So inlet flow rate, outlet flow rate of CF4, right? And now let's go down here to our options. We have a couple of neat options to play with. The first one here, apply DL to plots. That's the default is checked. You can see if I uncheck, if you look in this region here, you see the effect in the time series plots of applying the DL. Let's, for example, check out HF. HF, 0 at the inlet. Why? That's the raw data because it was BDL the entire time, right? So BDL at the inlet, 0. You can see how the outlet gets affected as well, replaced with the BDL value. Okay, going back to CF4, we have some, these next toggles are for how to calculate the DRE. We have include all data, which obviously means include everything within the windows. We have this automatic region select, which is the default. This will automatically determine the regions in the inlet and outlet in which to calculate the DRE result based upon the detection limit at the inlet. So for example, as we see here, this region here is below detection limit, so that would be auto removed from the outlet data. So only when the inlet is above DL will the outlet data be calculated for the DRE. And we've added this option. This is a lag in seconds. So this is if for some reason you have some residency time difference in the inlet and the outlet gas, and when it reaches the analyzer, you can institute a couple of second offset if, for example, it takes maybe 3 seconds longer for the outlet to register an event that the inlet already has registered, and you can also go backwards in time. Our last feature is this show region select. We can have up to 3 different regions, and you'll see they come in red, green, and blue colors for 1, 2, and 3. Here we can just slide and stretch these regions to manually determine where to calculate the DRE. We have this lock, so you can have them individually set on the inlet and outlet plots, or you can lock them together, and you'll see that when I move one, the other moves along with it. So now we're going to go to the DRE results tab, but before we do that, I'm going to switch this back to auto region select, and I'm going to jump over to the DRE results. At the top, we have our compound select. So again, we can choose which compounds we want to observe. I'll click CF4, and we have our results table, which is just a numeric display of the calculated DRE. And down below, we have a bar plot graphical representation of our DRE as well. We can plot as many of these as we want. So you can click through and add different compounds to what we're looking at. Notice when I click HF, no bar plot arises, and we get this field no data because there was no data at the inlet. So you cannot calculate the DRE. Also, if you were to click on any of these bar plots, you get this bubble that will arise telling you the total calculated outlet and inlet volumes used in the calculation. And obviously, I'm not running currently, but if you were running, these numbers would update with every point that was collected. I want to jump back here for a second to time series to show how the region selects work in the calculation. So I have my 3 regions selected. If I jump over to the DRE results, you'll see I now have 3 different colored bars for the red, the first, the green, the second, and the blue, the third region. And you can click on them to get your volumes, right? But this way you can see the difference in this graphical plot of the DRE within those 3 different regions. And then this tabular data, this would be the collective sum DRE for using all 3 regions. I hope that's clear. I hope this feature it will be helpful. But again, we default to auto region select, and hopefully auto region select will be the majority of the way that you run. But you have these options. Now what I want to do is point you down to some of these new buttons at the bottom. You'll see we have the start and the purges still, but we've added clear and save. So whenever you hit stop DRE test, the file is saved or the payload is sent, or both. But if you wanted to say you stopped your DRE and you wanted to make an adjustment, for example, you wanted to move these regions around, which obviously will affect your DRE results. Then once you've gotten your analysis the way you would like, you hit save, and that'll save a new file of those results. And also I have a clear button. This clear button will obviously do clear to wipe the screens and remove all data from memory. But what it also does is if you hit clear and then start another DRE test, they will write different files, right? So for example, if you were say tuning a burner, you could perform the first run, get your DRE, perform your tuning operation, simply hit clear and start again. You'd write a new file, and that would be for your your second step of the optimization process, and so on. So that's it in a nutshell. Really crammed through. I hope that was clear. One thing I'd like to do now is show you an example of the file that is being written, which is completely new. I have two of them pulled up here. Here is, so they're going to end in this .dre extension. They are obviously human readable, tab delimited, so you can drop them into Excel like I've done here. And you've got fab ID, POU ID, inlet outlet, and a date and a time stamp up here. And we've got some like metadata information down here, fab, POU, source. Here's a location to where the saved flow file was, what type of the sampling type was, our total flow for the outlet, and then some how we determine the regions and whatnot. But what we have as far as data that's stored is our timestamp. So you have a human readable and a Unix style timestamp. But then we have 5 fields for every compound. So we have our measurement and concentration, our DL alongside it, our total volume of that compound, and the DL in total volume. And lastly, we have this include flag. So you'll see every compound has an include flag. This is like a binary bit flag. It'll always only be 0 or 1, and it indicates which of these values to use in the DRE calculation. So for example, for C3F8, this 0 indicates that this point was deemed to not be used. And this whole file, I should say, was generated using the auto region select. And so it automatically chose, it said this one is BDL at the inlet. These two were not BDL at the inlet, so we would use these 2 points in the calculation and so forth. And hopefully you can see, with a little Excel functions, you could easily recalculate this DRE from the data presented here. And I'll show the inlet. The inlet's the same style, but so you have one of these files for the inlet and the outlet. Notice the inlet up here and the inlet marker here. Same thing, all your compounds and your concentration DL, volume DL, and your include flag. And one thing I need to add, if you go all the way to the end, we have this time field, and notice it's in minutes. So this is the amount of time that the sampling occurred on each individual point. So you can much more easily determine the length of times for each data point to use in subsequent calculations. I forgot to mention one last thing. Here you can see we're on the DRE measurement page, the final one, but we are in sequential sampling mode. So in sequential sampling mode, you'll see our buttons down here at the bottom are gone, and instead they've replaced with this external pop-up window here. And here we've split the controls into the inlet and the outlet FTIR. So you can start the inlet DRE whenever you're ready, clear the data, save the data. So it's the same functionality as the buttons we had below, but they're split into the inlet and outlet controls. So you can run, say, the inlet first, then when you're ready and the in situ plasma is on, you can go ahead and start the outlet measurement. Other than that, there's only one other difference. You'll see here in our options on the time series tab, we've replaced the auto region option because in sequential mode, they're by nature split in time. And so the sequential logic was no longer applicable. So I replaced it with this compound threshold. So basically what this means is, of this list of compounds, you can click the drop down, you can choose a compound. It defaults to HF for the sake of the in situ plasma operation. You can define the threshold in which the outlet will trigger, say, some value, say 50 milliliters a minute. And so everything above, once the HF concentration rises above this threshold value, it will apply the DRE regioning for data point choosing to every compound where HF is above that value. So keep that in mind, guys, and I will, and that's all I have for the sequential. And we're back. There's one last feature I wanted to talk about that I forgot in the original video, so I'm creating another one that I'll append to the end of the last one. Notice here this pop-up window that has occurred. It says a backup file was found from this timestamp. Would you like to continue this measurement? So we've added save states to the automated DRE. So if you are in any of the pages prior to the actual DRE measurement page that we just discussed in detail, when you go to close the program, you'll have a window that pops up and says, that it's going to save this file. Are you sure you're ready to quit? And if you say, okay, I want to quit, next time you open it, you will see that it has this window right here arise, and it's saying, would you like to continue where you left off because you didn't finish your previous test? So I can discard it, and then the window would disappear, and I can start over, or I can hit open, and this will allow me to start off where I left off, continue where I left off. So you see, give it a second here to load. And here we go. So I ended on this tab. You see it repopulated all this information. So I can go ahead and continue on. And for an example, let me show you what happens when we close. So I'm not to the final page yet. So if I close here, I will get this message. When you read this, the current page's data will not be saved. To save this page's data, select retry and then select the next button. Or you can close without saving and hit ignore. So ignore will go ahead and close it. What this means is when you hit next is when this backup file is saved. So for example, if I was on this inlet flow run and I had done all of this inlet measurement, but I needed to quit and resume at a later time, this message is to alert you that, hey, if you're done, if there's work on this page to save, hit next and then quit. So if I do retry, it lets me come back. I can hit next. Now I've saved that information, and now I'm safe to close. All right, thanks.